Alright, so in this video, we're talking about complex numbers. Complex numbers are just numbers that have an I in it. Sometimes you'll hear imaginary numbers because it has the I, but I'm going to call them complex. Alright, so basically our properties of complex numbers are very similar to if it was an X. So if we're adding or subtracting, so like the first example here, 4i plus 5i is just 9i. So it's very similar to our x values. 6i minus 2i is 4i, and 4i minus 9i is negative 5. So adding and subtracting is easy. Just the I doesn't disappear. It's very similar to if it was 4x plus 5x, it's 9x. I is not a variable. It's a symbol for a complex number, but the properties of it act similar to if it was a variable. All right, multiplying gets a little trickier. There's one exception to the rule. I'm going to write that up top. So I squared is equal to negative 1. So I squared is equal to negative 1. So the only difference between this and a normal like x would be if we get x squared, it doesn't matter. We just have x squared. If we solve it out and get I squared, we turn the I squared into a negative 1. So if you look at the first example, we have 3i times 2i. 3 times 2 is 6. 3 times 2 is 6. I times I is I squared. This I squared is negative 1. So we have 6 times negative 1. So it's actually negative 6. So 3i times 2i is 6i squared. But the I squared, if we're solving a problem and end up with an I squared, we turn the I squared into a negative 1. So 6 times negative 1 is really just negative 6. The middle problem, where we have two basically like factors like we had with the quadratic on our last test. To multiply these out, we distribute like we did last week. So we have to do 2 times 3, which is 6. 2 times 2i, which is 4i. I times 3, which is 3i. And then I times 2i, which is 2i, maybe, 2i squared. All right, the 6 just hangs out. 4i plus 3i is 7i. And then we have I squared again. So that's plus 2 times negative 1, which is 6 plus 7i minus 2. 6 minus 2 is 4. So we took those two factors of 2 plus I and 3 plus 2i. We distributed it out, and we ended up with an answer of 4 plus 7i after we combined like terms. So the key with multiplying is everywhere you get an I squared, I don't care if it happened once or 20 times, every time you see I squared, we need to be replacing it with negative 1. All right, one more. So here, just like the last one, we're going to distribute. So 2 times 2 is 4. 2 times negative I is negative 2i. I times 2 is plus 2i. And I times negative I is negative I squared. Oh, geez. Sorry. Rewind if you need to see that past work. My iPad just crashed. So let's do that again. So 2 times 2 is 4. 2 times negative I is negative 2I. I times 2 is plus 2I. And I and negative I is negative I squared. So in the middle there we have negative 2I plus 2I. Well, that cancels. So I'm just left with negative 4 minus I squared. I know I squared is really just negative 1, which means this is 4 plus 1, because negative negative is a plus. So my answer to 2 plus I, 2 minus I is actually just the number 5. Sorry that the first two where it disappeared. You can rewind the video if you need to. But multiplying follows the same properties as a variable, essentially, except everywhere we see an I squared, everywhere you see an I squared, it equals negative 1.